This is section 222. We're going to take a look at radicals and imaginary numbers. This should be a review though. So we're going to learn how to reduce a radical and understand what a negative inside of a radical represents. So, how do we simplify radicals? Simple answer, reduce perfect roots. And by doing that, we want to try and factor it. Now just remember, factoring means we are breaking it into multiplication. So we're going to break it or factor it into perfect roots, and things will simplify. So here we go, the big square root of 72. So I have to think to myself, what is a perfect root that goes into 72? So, 9 times 8. 9 times 8. That is 72. So, the reason why I chose 9 is because 9 is a perfect root. 9 is 3, and I still have that root 8. But now I have to think, is there a perfect root inside of 8? Oh yeah, square root of 4, square root of 2. Well, the square root of 4 is 2. So I take all of those and I multiply them together. So 3 times 2 is 6, and I still have that radical 2. Simple. Next one. 20, x to the 4th, y to the 6. Now we have to do the same idea. We want to break this up real quick. So I have the square root of 20, and I have the square root of x to the 4th, and I have the square root of y to the 6. Now we don't necessarily have to break it up like this, but I'm just doing it because it's easier to visualize. So first, what are the perfect roots inside the 20? Okay, well that's going to be the square root of 4 and the square root of 5. Square root of 4 is 2. Okay, so we got that piece done. Now the square root of x to the 4th. So I have to think to myself, how many x squareds, which are perfect squares, exist inside that square root? So I have 1 and 2, because x squared and x squared gives me x to the 4th, so that just simplifies into x, and that's just an x. And then with my y, that's actually 1, 2, 3, because 1, 2, 3, 4, 5, 6, that adds up to 6. And so that's going to be y, y, and y. So combining all these together, I have 2 x squared, since I have 2 of them, y to the 3rd, since I have 3 of them, and I still have that square root of 5. Now, whenever that number changes, that means instead of thinking of perfect squares, I need to think perfect fourths, like to the 4th power. Another way of doing this would be, I need that many factors being the same. So going to this previous one, the reason why the square root of 4 works is because that's actually 2 times 2. I have 2 of the same factor. The reason why in this instance here, the reason why 9 works is because the square root of 9 is actually 3 times 3. I have 2 of them. Well, a square root means you need to have 2 of them. Well, if I have a 4th root, that means I need to have 4 of them. So sometimes multiplying them all out or completely factoring everything is another way to help us out. So for example, 32 is 2 times 2, which is 4, 8, 16, 32. And then with x, I have 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And with my y, I have 6 of them. 1, 2, 3, 4, 5, 6. So, 4th root means you need to have 4 of them. So that gives me a 2. I still have this inside the 4th root. I have 1, 2, 3, and then here I have a y. And so what's left inside my root is 2y squared. And that's my answer. Now, I know this is a more complicated one. If you're still a little confused, that's okay. We're going to be working through things. It doesn't need to be mastered right now, but just know that this is another way to break it out. Fourth root, if that said fifth root, I need 5 of them to be able to bring one out. So now let's talk about complex numbers, or I. As a reminder, the square root of a negative number equals I. Now, the reason being is in this statement here, x squared equals negative 1, there's no value that you can plug in that gives me negative 1. Now, I know what you're thinking. Well, Mr. Duval, if you plug in negative 1, that's going to give you 1. Nope, because if you square the negative 1 times negative 1, negative times a negative is a positive. There is impossible, there's no real number that you can pick that you can plug in and give that. So that's where the imaginary numbers come in. And so 2 definitions that you should know. I know, I did a bad thing, but I'm going to say it right here. You guys need to know this. This is a good flashcard piece. I equals the square root of negative 1, and I squared equals negative 1. Now, when we simplify these, we always are going to break out the negative part. So in this instance, I'm going to break apart that square root of negative 7 into the square root of negative 1 and then root 7. Well, the square root of negative 1 is I, and then so I can write it as root 7I. For here, the square root of negative 16, we want to break that apart. There's my imaginary part, and then there's the root 16. Well, root 16 is 4, and so you get 4I. So remember, we want to break out that square root of negative 1 part. This next one, that negative is still on the outside. That's okay, just leave it on the outside. You do not multiply those together. So I have the negative still, but then now I have to break that into the square root of negative 1 and then 13. That turns into I, so negative I, and that's still root 13, so I get negative root 13I. This one here, same idea, break it apart with the negative, and then now I have the root 48. Well, that breaks into 16 and 3. 16 is a perfect square, which is why I broke it into that perfect square. 16 turns into 4, so I have the I, 4, and root 3. So that's going to be 4 root 3I. So just reinforcing complex numbers in the form of a plus bi. We're going to talk about them again a little bit later, but I just wanted to emphasize the fact that if we have imaginary numbers, they just combine together like they do any other combining like terms. So for example, 8 plus 3 is 11, 6i plus 2i is 8i. They just combine together. The negative, you got to distribute the negative. So you're going to get negative 6, and negative is a positive. 4 and minus 6 is negative 2. And then 5i and 3i give me 8i. Combine like terms. That's all it is. To remember, if we multiply and if we ever get an I squared, just know that it's negative 1. So when I distribute this problem here, 1 times 1, I know some of you guys are used to writing everything in the box. So 1 and 2i, 1 and 3i, and you guys multiply that together. That's fine. So 1 times 1 is 1, 1 times 3i, 2i times 1, 2i times 3i. Well, I times I gives me I squared. So that means, combining like terms, 1, 3i and 2i give me 5i, but this I squared gives me negative 1. And so 6 times negative 1, that's going to give me negative 5 plus 5i. And so we have that there. Remember, this does not mean you distribute that 2. No, no, no. It means I have 2 of these. So 3 minus 7i and 3 minus 7i. And so you'd go through and you distribute all of that. But I'm going to quickly skip through that. If you guys want to work on it on your own and take a look at it, that should be your final answer. The last little piece I wanted to get to here was what happens if we keep raising I to a power. And in this instance here, if we keep doing it, what ends up happening is it actually becomes cyclic. And it follows this pattern of I, -1, -I, 1. I, -1, -I, 1. And so because it is cyclic, if we just remember this part, I is I squared is -1, I to the third is -I to the fourth is 1, the pattern is all I have to do is divide what my power is into 4, whatever the remainder is going to be what it simplifies into. So for example, if I have I to the 37th, I take 37 and divide that into 4. 4 goes into 37 9 times, distribute. There's my remainder. So because my remainder is 1, it simplifies into I. And there's like the visualization of that. If I took 58, divide that into 4, I get remainder 2. So because it's remainder 2, that's I squared, therefore it's going to be -1. So what did we learn today? We learned about complex numbers, we learned about square root of -1, and we talked about how to simplify or reduce a radical equation. And so how do we reduce a radical equation? We simplified perfect squares out of the radical. So like if I had the square root of 18, we broke that up into square root of 9 and square root of 2, so that's going to be 3. And then what is I? I is the square root of -1. It is an imaginary, non-real number. This does conclude our lesson. If you have any other questions, please leave them in the comments.